Hey, this is Jason Clark here again at South Dakota State University, and welcome back to our webinar series on nitrogen fertilizer recommendations for corn. In this video, we're going to be talking about the legume credit and why we need it and how accurate it is with it and without it. So let's go. So far we've talked about how we need to set a yield goal that's realistic, multiply that by our 1.2 coefficient, subtract our soil test nitrogen, and now we're going to be talking about the need to subtract our legume credits. And the ones that have credits are those with previous legumes, such as soybean and alfalfa. This credit is all likely due to the carbon to nitrogen ratio of that previous crop. So if we look at this graph here, we'll see why that carbon nitrogen ratio is important. As we look over time, that carbon nitrogen ratio tends to decrease. But when we're up in this 30 to 60 range or higher, we see a net immobilization of nitrogen by microbes. That means nitrogen is being taken from the soil that's plant available, used by the microbes to break down residues and other materials in the soil. And then once that level goes below 30 to 20, we see a net zero amount, meaning that it's a 1-to-1 ratio. The microbes take 1 unit of nitrogen from the soil to decompose, they're releasing 1 unit. Once we get below that C to N ratio of 20, we start seeing mineralization of nitrogen, meaning microbes are releasing more nitrogen to the soil than they are using to decompose the organic matter in the soil. And that's what we want. When that corn crop hits about V6 and is ready to take up lots of nitrogen, we want our C to N ratio of our residue being below that 20 range. So we're releasing nitrogen, feeding that corn crop when it needs it, and that'll reduce the amount of nitrogen we need to apply as fertilizers. So if we look at some of our previous crops and where they fit on this graph, we see corn is around 57, soybean 33, wheat 80, and alfalfa 13 to 25, depending on when we harvest it. So you can see these legume crops of soybean and alfalfa are much lower on the C to N ratio, which is likely why they start mineralizing when corn needs it faster, so they require less nitrogen, whereas corn and wheat are likely still in that immobilization phase when that corn needs lots of nitrogen, so we actually need to put more fertilizer on to get to our optimal yields. So here, if we take our soybean corn and our corn rotation, and we look at a figure right here where we have corn yield on our y-axis and our nitrogen rate on our x-axis, here's a question for you. So if you were to draw these two curves of how yield related to nitrogen rate for corn and soybean corn, what would they look like? Go ahead and hit pause on the video and draw it out on your mind, otherwise I'm about to spoil it. So if we take our corn after corn, we normally see this. We see that increasing yield as we increase until we hit an optimum point where we no longer see yield increase, which in this case is just above 150 pounds of nitrogen. If we relate that to our soybean corn rotation, we see the same type of curve. We increase until we hit a certain point, and that point is just above 100 pounds of nitrogen per acre here. If we look at the values of how much nitrogen was required to hit optimal yield and how much yield we receive, this is a trend we see. We normally see an increase of yield when we plant corn after soybean, and we see a reduction in that nitrogen fertilizer requirement, and that reduction is around 40 pounds of nitrogen per acre on average, which is where that credit comes from. So now if we transition to looking at alfalfa corn rotation, and if we look at the 4 site years of this, 2 in coarse textured soils and 2 in fine textured soils, we again see the same trends in all of these years. 0 nitrogen fertilizer was required. So if we look at our data just here in South Dakota and look at our previous crop being soybean or wheat and their optimal nitrogen rate, we see soybean around 65, wheat around 96. So on average, a decrease of 30 pounds of nitrogen per acre that's needed. A little less than our 40 pounds per acre, but if we increase the amount of sites that we have, this could likely continue to increase as well. So now we want to see our accuracy of when we include this legume credit and when we don't. So again, here we want to see lines close to 0, because that means that we're exactly on our optimal nitrogen rate needed versus our recommendation. So our red line is where we have no legume credit. Above the line overestimation, below the line underestimation. So we add that legume credit of 30 pounds, so we decrease our nitrogen fertilizer recommendation by that much. In all these instances, except for a couple, we see we become closer to 0. We're more accurate when we use that legume credit, showing that we need to. So again, just review here, yield goal, multiply that by that 1.2 coefficient, subtract our soil test nitrogen, then we're going to subtract our legume credit, which in this case we're going to say is soybean, so 40 pounds of nitrogen per acre. Next up is our no-till debit and how we would determine that. So stay tuned and click on that next video. Join us on social media to get research updates